Jolanda Stevens, Henri, Werij en Brian Moran.
Ga je niet over elektrisch vliegen hebben? Ja?
So thank you, panelists, for joining this last panel, and I will do a short introduction. And the first one I would like to introduce is Jolanda Stevens. Welcome, you're head zero emissions at KLM. Maybe a starting statement to warm up. How do you think the aircraft of the future will look like?
Wow. Well, I think you don't have to ask me, but I should look at the audience, right? Because I think the future of aviation and what aircraft will look like is sitting right here in front of me. But since you're asking me, of course, it was an evasion to get some time to think. I hope that there will be a large array of different aircraft, more than we have today, because if you look at the design of the aircraft, and you know better than me, the heart of the aircraft design is the propulsion system. And since so many things are differing, are now changing, and you see it already in the upcoming new eVTOLs and smaller aircraft, I think we will see a lot of different shapes in 2050. So that would be my answer.
Thank you. Moving to you, Brian, welcome. You're the Vice President Global Sustainability Policy and Partnerships at Boeing. Well, the company name, it was already mentioned a few times. So what is your view about the aircraft of the future?
First of all, thank you to Delft and the VSV for the exciting forum that you guys put together. It's exciting, and we're honored to be here. I think airplanes will look very similar to the way they do right now. A bit of a provocative statement, not to contradict what you just said. I think clearly eVTOL will take all kinds of shapes, but the tube and wing design has been with us for the better part of the century because it works and because it's the most efficient way to design it. You know, 15 years ago, together with Cranfield University, we flew two scaled prototypes of a blended wing body design, X-48B and X-48C, did about 170 flights. And we learned a lot in that. Clearly for maybe some military cargo application, there's some opportunity there. But I think Victor talked earlier about the passenger experience if you're sitting on the edge, the evac, the safety consideration. So we learned a lot. I'm not going to rule it out, but it's highly unlikely, I think, that it's going to look different. But we also shouldn't forget the amount of innovation that the current design has brought us. You know, since Boeing launched the 707 and took us into the jet age, we took down 70% emissions and 90% of noise. And there's a long runway ahead of us that I'm excited to talk about later today.
Okay, thank you. Henri, I don't know if I should introduce you, but I will, but probably everyone knows you. You're the Dean at the Faculty of the Aerospace Engineering at TU Delft. What's your view on that?
Well, to be honest, I think there is a chance that aircraft will look differently. Okay. Of course, tube and wing is a proven design. We have to take into account that we might need more storage space for hydrogen, for instance. You can do that in the tube. You can also, in the design that was shown by Victor, a flying V or a blended wing, you might have more space. I think that is really a serious opportunity. But I also think that wings themselves will change quite a bit. So we are thinking about autonomously deforming wings, morphing wings that sense what the air is doing. That's what we are working on in order to essentially lower the drag, optimize the wing for the current conditions, and also be able to make it lighter because you can alleviate the gust factors and things like that. So I think these are some things we will see in the future. But I think planes will look differently and will depend on what kind of energy carrier we have on board, and there we have more choices.
Well, I must say I'm the airport guy or woman, but so I don't have very much knowledge on the development of aircraft. But I'm really interested in this exciting period of time we're in at the moment with all the different developments, and whether it will be battery or hydrogen or SAF or whatever. It's interesting to follow and to know what happens and what's the impact on the airports, because this is very important for us to know in front and to start working with you guys from the aircraft companies to know how it will affect our future development, and to most of the time be helpful to develop your future.
If I may, a great example of that is the 777X, which we're certifying right now. It's still a tube and a wing, but the outer 3 meters of the wing fold up like an F-18. And so you taxi out with the wings up, and then for takeoff, you extend the total wingspan by 6 meters. And we did that to stay compliant with the current regulation. I think it's Code F, to stay within the parameter. And the other design, and don't have the time to go into it today, but the transonic truss brace wing, a competition we just won with NASA, that's going to be $1 billion we're going to invest in 2 flying prototypes with a high aspect ratio wing that creates much more space under the wing for new novel propulsion ideas that our friends at GE and other engine companies are coming up with.
So the A380
and the A380,
changed
yes.
the layout of Schiphol, and they had to invest a lot. So now they have to rebuild again. So, well, it's interesting for the airports as well what your developments are.
So I think you agree with Henri.
Well, look, it's going to be, I think the infrastructure, it's going to be a constant tug and pull.
Yeah.
We talked a lot today about the hydrogen infrastructure, and a beautiful example that you all are setting. You know, we have some experience from the space business, ironically. We had this little rocket sitting at the Kennedy Space Center called Artemis that just flew around the moon. And it took 3 attempts, and the last attempt that finally went, we almost aborted within the 10-second countdown because of a hydrogen leak. And so the experience around handling hydrogen, to your point, is something that can't be discounted. And that's flying once, not flying thousands and thousands of times a day and turning around at airports like Groningen where you're going to have the skill and the safety measures for that. So that's why it gives us pause. And very much to the question earlier about the difference between Boeing and Airbus right now, I think we're actually pretty aligned. Fleet renewal will always generate 15 to 25%. That's what the A320neo did. That's what the MAX did. Operational efficiency, very much. You look at some of the leaders like LVNL. There is a lot of inefficiency still stuck in the skies, and not all ANSPs are as forward-leaning as LVNL. So using the digital technology that's inherent in the airplane versus some of the radar technology from the 50s. But I think it's the second last pillars where Boeing and Airbus disagree a little bit and have different points of emphasis. And that's renewable energy, where we are leaning on SAF as the baseline. Victor showed the most important chart today, which was a checkers board chart that showed you time on the x-axis and then down on the y-axis, the payload and range. What we didn't talk about is the fine print that said that 73% of emissions happen in the mid to long haul. We had this thing called the Taylor 250s, that says that 50% of all flights are under 1,000 kilometers. But that's only 15% of global emissions. And if you flip it, 50% of emissions is 2,800 kilometers or more. So we are focused heavily on, you saw the green across all those checkerboards, that's SAF. We don't have the luxury of foregoing SAF if we're going to decarbonize by 2050, which is why Boeing has been invested in that from the very first flight in 2008, to flying the first airplane on 100% SAF in 2018. And now committing that by 2030, all of our airplanes will be 100% SAF capable. And by the way, this is a technology student body. Don't let that intimidate you saying, well, there's no innovation left. There is a ton of innovation left in aerospace. On the hydrogen side, on the battery electric side, which we're working on, we can talk about later a little bit. But our emphasis has been SAF and electric, SAF and hydrogen, but with a focus on SAF.
Thank you. Henri, you want to?
I would like to comment a little bit. I get the feeling that Boeing is indeed focusing very much on SAF. That's what I mainly hear. Let's not talk about batteries, because then we are only addressing a few percent.
Yeah.
Because, if any.
Yeah.
But if we are only talking about SAF, any plane then is sustainable. I hear it from Boom as well. In the US, they say we are a sustainable aircraft because we use SAF. We use 10 times as much per passenger kilometer. In my opinion, that's not sustainable. The problem that we are facing is that we have a lack of sustainable energy to start with.
Agree.
So if we are talking about SAF, I'm mainly talking about power to liquid. Biofuel is going to be a problem because we need so much. So if you're talking about power to liquid, we have to make sure that we have We need the smallest amount of sustainable energy to start with per passenger kilometer. And in my opinion then, we cannot leave out hydrogen. I don't say that hydrogen is going to be the solution for up to 10,000 kilometers, but perhaps 4,000 could be. And 4,000 kilometers, then we address about 2/3 of the energy consumption.
Yeah,
so
I agree with you. It's, by the way, that same renewable electricity that we would need for e-fuels is that we will need for hydrogen production.
Absolutely.
So then you have to figure out, we go around this circle, do the physics work, and we have literally charts on our walls that say how many Nobel Prizes are we away from closing it. When you do that, the second is, can you get it safely certified? And it has to be as safe or safer than the current. You already made that point. And then third, and this is a point that's missed right now, is what is the total climate impact of that? And that's because 95% of today's hydrogen is not green. So I heard all the investments being made in Europe, and I hope they come to fruition. But as we sit here, if we had hydrogen airplanes, the carbon intensity and the total climate impact of those airplanes would actually be positive, not negative, not good. And then lastly, it has to make business sense for these guys. And I welcome you in this conversation. So don't hear us say that we're not investing in this. We flew the first passenger flight on a hydrogen fuel cell in 2008. Last year, we had a 16,000-gallon linerless cryogenic composite fuel tank for a composite application in space that we're using now for future flight concepts. We're just far less vocal externally, as maybe some other folks are, about the potential. And here's why. By 2045, there'll be 45,000 airplanes, conventional airplanes, flying. Those airplanes, to decarbonize them 5 years later, will require SAF.
Absolutely, I agree there. But one thing I don't buy, you say, well, currently 95% of the hydrogen is not green. Then how are we going to make the SAF green? If we have the power to liquid, we have hydrogen in between. So
exactly.
If that is a problem for hydrogen, which we have to
solve,
it's a problem for SAF.
No, and that's why, you're absolutely right, and that's why we say for hydrogen, the first, the best, and maybe the only application for green hydrogen is to produce SAF as a drop-in fuel for the 45,000 airplanes that are going to be out there that'll have to be decarbonized by the middle of the century.
But if you look at the energy consumption per passenger kilometer for a certain range, you might be better off if you use hydrogen.
You're right. Look,
I think it's a really interesting conversation, but really, so.
Maybe we should go.
Yeah.
Let's bring the customer.
I want to bring the customer in. Jolanda, what's your view on this?
Well, on this, it's a very big topic we're touching here. So, but of course, I hear the two sides of the opinion here talking about SAF. And of course, if we are looking at our core business, we are doing long haul, right? So I agree, we have to massively produce SAF and invest in that. However, also, if I saw the layered cake charts earlier with Victor, but also with Volker, I think, we also see that there's several solutions parallel to each other. And for us, as the customer, representing the customer in operations, we firmly believe that we have to really take a very close look at the three different tech streams being developed here. Because there is no silver bullet, everybody knows the same phrase. And also for us, I think that goes, because we are not only surfing long haul, but we're also surfing the medium and shorter haul. And eventually, if we keep doing like we are doing today, we are not going to achieve anything. So if we want to achieve a better world, because I think that's what we are talking about here, and we're not talking about the chemical components of the fuel. We're talking about a better world here and about sustainability. And what are we going to do to give our best push towards this cleaner future? That means that we have to rethink what are we actually doing here. And what we are actually doing here is we are providing mobility to a large amount of people. And I think we are providing mobility to the people who are sitting in this room, and they are not sitting at the front. At the front, is the current generation, but our future generation is in the back, which I think is the reverse order. So I think next time we have to do it the other way around, because we are going to transport you guys. And are you still okay with the fact that we are flying to Kuala Lumpur in one stretch? Maybe we will not be okay with that anymore. I don't know the answer. The only thing, my job is to take a look at what we are doing and really question ourselves as a very old, existing company. We are old. We have to rethink ourselves.
Sorry to interrupt you, but do you think climate neutral aviation by 2050 is feasible?
Well, I think we have to believe that. Because if we don't believe it, then we will give up. So, of course, we believe that. Yeah. It's going to be very tough. We also saw that in all the different presentations. But I firmly believe that if we look at the 3 different tax streams, that we can, to speak with, how did our football coach say it? We'll come a whole end or something? Louis van Gaal? Something like that. We will come a whole way or a whole end. I think we will come a whole end. Yeah, I think so. But, of course, we will not make it all the way, probably. And also the layered cake chart shows that, so there will be offsetting. And I think we shouldn't look at offsetting in a traditional sense. So only planting trees will not get us there, but there will be a lot of low-hanging fruits in other sectors. So what if we make households more sustainable? It will be maybe a lot easier than turning aviation in a different direction. So maybe our money should go there in the offsetting part. And we have to do our part. So that's what I'm trying.
I fully agree with you, because I think it's also a broader system, a more holistic view. You have talked about that earlier. Yeah. Because it's all about connectivity. It's all about dividing the wealth between several kinds of countries, even in Holland. It's not divided right, I think. So we should discuss it in a better, broader way than only about, is it SAF, is it electric, or is it sustainable aviation fuels, or is it hydrogen or synthetic fuel, or perhaps there are more others. So I think it's better to have a broader discussion in the whole. Yeah. So I fully agree with you.
I agree with that. To answer your question, I absolutely think we'll get there. And there'll be a residual amount of offset. The ATAC charts clearly show it. Where we put the emphasis, whether it's 50% SAF or 75, it doesn't matter. That's what the studies show. But on the technologies, this is a technology forum. Look at on the electric side. We're working with GE on a $250 million contract with NASA on the electric propulsion flight demonstrator, taking a Saab 340 and having a megawatt class hybrid propulsion engine. That's going to address, I think in 2019, it was about 8% of the block kilometers were in sort of the 49-seat category. That's going to address that small bit. We're working on hydrogen and flying the prototypes and working on de-risking there. But to your societal benefits, I think that is probably the most important part. You mentioned a great statistic earlier that 80% of the people in this world have never set foot on an airplane, and they deserve to. I know there's sort of a question of do we need to stop flying? It's not for us to sit here in these advanced economies deciding whether I should fly to Brussels or not. I mean, of course we shouldn't. I mean, I think the campaign you guys did on considering taking the train for shorter routes is obvious and it's perfect. But it's the economies that depend on economic development. It's the 4.1% of global GDP that depends on aviation, the 89 million jobs that are attached to it. That's what we're talking about, and so I think it's your guys' responsibility with assistance from civil society to find a way to make that happen, and I definitely think we will.
And Brian, maybe another statement. Do you think we should focus more on the short-term sustainable?
At the risk of launching another argument, I honestly think that 2050 is short-term. You guys showed the charts, and there were the other companies, but we have the same development cycle. So today, and the products you all will be working on will define whether or not we make it in 2045. We're one airplane. Unfortunately, the gentleman who asked the question has since left. I was going to answer his question on will there be another conventionally powered airplane. I think there will be. Because for us, we see hydrogen coming in the second half of the century. Again, it doesn't mean we're not working it today, but at scale, it'll happen the second half of the century, which is why we're so focused on SAF, by the way, just to clean that up. But the decisions are being made today. The transonic truss brace wing, which will fly by the end of this decade, I mean, it's going to take us 5 or 6 years to develop that technology. There's this new and novel aerodynamics that hadn't been done before. That'll inform the next airplane. And then that airplane will take 10-ish years to develop. And then to get up in production rate, think about this. Boeing and Airbus together build about in a good year, build about 1,000 airplanes. We have to replace 45,000 airplanes by 2045. This is why I'm so passionate about the sand chart is right, but it comes in a sequel. You have to think through it. It's not everything at the same time. The thing about strategy, it's all about choice. And we have to make choice. You can't do everything always. You have to allocate your resources smartly because you don't have unlimited resources when you go into your companies. And so that's why we're so passionate about making SAF the baseline and working on electric and working on hydrogen.
If I may add one thing, and it's coming back to the last question about climate neutral versus carbon neutral. Yeah. I noticed that quite often these terms are being used intermixed, and it's absolutely not the same. So we have to take into account climate neutrality, takes into account the non-CO2 effects, and these are actually even bigger than CO2. If we only solve carbon, we are not there yet, so we have to take that into account. That's something, well, like we just heard, is being worked on. We are looking at NOx, we are looking at contrails, and this is a very important point. If we are not going to address this, we might be carbon neutral and still we have a big problem. So I think it's very important to address that and make sure that all of us focus on that as well. And therefore I think aviation might look differently. We might fly at different altitudes. Our operation has to be different as well. And therefore we need this holistic view. It's not only the aircraft builders, but also how we use it. And LVNL is going to play a role there as well.
Yes, and also ground operations, for example, I think plays also a really important role here.
Yes, because otherwise you don't have a solution if you don't have the softs or the hydrogen in place. But one issue, I think it's important. It's important to get our footprint smaller. It's important. On the other hand, we just talked about that some people have nothing and other people have everything. In Europe, it's important to have their less dense populated areas. You would like to connect them with other dense populated areas. That's one of the statements from the European Commission as well, to get more connections within Europe. And I think electric flying with batteries will not solve the problem of the footprint, but it will connect people. And therefore it has another important social aspect. And I think we should separate those discussions. I sometimes have them with Henri, it's great. But we should, I realize that we should separate those discussions, but we should not only focus on the footprint, but also on the social aspects of living in this world. So it's the footprint of we're all doing to our Earth, but it's also how we live together and who is going to fly and who's not going to fly.
Now, you addressed the point of electric. What I also so amazed about, if I hear electric, people say battery electric. Now we have battery electric and fuel cell electric, and I think it will always be a combination. But the point, if you're only talking about battery electric, I would be interested to see a calculation where you can show that you can fly more than 250 kilometers, having all the safety ranges in place as well. In aviation, everything is about safety. You have to do a holding pattern, you have to do a go around, you have to go to an alternative airport, and then still have half an hour of energy on board. If you subtract that, you have nothing left for full battery electric.
I agree, Henri. So we're not on this different discussion, or we're in a different discussion. But if I look at Groningen, we're in the middle of nowhere. It's a bit too sad, but we're very close to Scandinavia. It's very close. If you want to go to Esbjerg, you have to take a car. There's a lot of economic activities in the northern part of Groningen, which is also in Esbjerg, because of the wind on sea development. So we would like to go, our people from northern part of Groningen to Esbjerg. So we take the car, or we go via Schiphol, but it takes 6 hours. If we could fly, it's about 2-hour flight or a 1-hour flight. It takes 200 kilometers. We can fly on a battery. And I think this is the important thing. I don't want to fly to the southern part of Spain or something like that. No, it's just to connect regions in a better way. That's my point.
100 kilometers, fine.
Yeah, so I think the development of the batteries, but you're the guys from the technique, so, and the Eindhoven University is more for the batteries, I think, but okay, find it out. I think there are a lot of developments there, and we should look in the future, not the state of the technology today. So, but discussion about the battery, etc., is another discussion, I think, interesting discussion, but I see a lot of possibilities to work on electric aviation, to have especially the connectivity between the regions, to get it in a more better stage. So it's all about mobility. It's all about getting the world more connected.
That circle I described earlier, it always starts with physics. And to Henri's point, I mean, Hard Electric is actually, I don't like to talk about other companies, but did the perfect case study in their own words. So if you haven't read this, when they changed from their 19-seater to their, I think, 30-seater now, and went from battery electric to a hybrid, it's because they didn't have any reserves left. And this is their own CEO talking openly about this. So it's a great case study if you haven't read it. But it always starts with physics, and when the physics close, then you check the certification and making it safer than the one you're replacing. It is very straightforward, and the customer business case has to close. And I feel like some companies walk the circle the other direction, sort of with ambition and hope, and then finally they get back to the physics and they realize that they don't close. So that's where we're very diligent, walking the circle the right way. And in some cases that makes us appear less ambitious, but trust me, behind the curtain there's a lot of activity going on.
I think it's very, well, if I look at the discussion we're having here, or the dialogue rather, I would say, what I think is really important to remember, and somebody earlier said something about competition. I think that's a very good question. Are we competing with each other? Are we trying to get better? Are we trying to get richer? And once again, that's also what's underneath this discussion is not the fact, am I right, are they wrong? No, I don't think we should go there. I think we should solve our own problem. So as an operator, we should solve our own problems. And we have to make our choices. And we have to try to understand what you are offering us. And if that's feasible and if we can use it. And I think every OEM or every operator or every airport should do that for themselves. And well, and in doing so, I think I think Victor started the day with that today. We have to collaborate. And in collaboration, we find mutual agreements and we find mutual solutions. And so this is the way how we're going to win over this big challenge for the future. And everybody should do that for themselves, being the technique of electric or being hydrogen. But I think we shouldn't have to debate against each other, but with each other.
But Jolanda, if I may add something, it's not against each other, it's about the laws of physics at some point. If you really can show that things are not going to work, fantasy is not going to get you there. So what we have to make sure that we are not spending our effort on things that are going nowhere, because we have no time to waste. We have to act right now. And this is the point. And of course we want to learn. And of course we always need batteries as well. I'm not against batteries. I wish it would work. It would be wonderful. But we have to be realistic. And this is what's worrying me. Because we might be distracted. And we really have to act and get moving right away.
But I think, well, in my opinion, I think the dialogue should be made instead of the discussion. Of course, it's very good to keep the talk very. You have to keep each other sharp. That's good, and also from you're a scientist, so that's a very good point of view. I don't go there because, well, that's too difficult for me. Only being a very stupid or a little bit dumb ex-pilot, so I don't have a clue about physics. But I think it's a very good thing that a lot of different people are trying. And I think in the attempt to get to a better future, we might find something we haven't found before. And I think everybody should have the possibility to go there. So that's at least what I would applaud instead of discourage. That's my opinion.
You know,
that's a nice invitation. Brian, you want to add something?
One more thing.
One more thing.
Yeah, one more final thing. It's Bill Boeing had this wonderful quote in 1928. He said, "Let no new improvement in flying and flying equipment ever pass us by." And he said this to the small engineering pool that he had, and he admonished Boeing engineers to say, if there's an improvement in aerospace, it better be coming from us. And we think about this a lot internally, especially with a lot of the the ambitious statements being made on and some of the risks that are being taken. And again, if I look back from the 707 to the Apollo mission to take us to the moon, to the 787, the first composite airplane, I'm proud that we've been at the forefront. We want to keep it that way, but that's not to say that we're not going to collaborate. Of course it takes industry collaboration. Look at GE today on stage giving a great presentation about the work they're doing with Airbus. That's great. And we're doing a lot of work with GE too on the next capabilities. So there is a lot of, within antitrust regulation, there's a lot of sound collaboration as an ecosystem. We have to. 2050 is around the corner, and we're gonna get this done, but really through partnering and a healthy dose of competition, because that's what drives innovation and that's what pushes us forward.
For sure, well said. I want to look at the audience if there are any questions, and there are.
Yes, I was missing Esme here because I would have loved to hear.
I'm Esme today.
That's okay. That's okay. I would have loved to hear a government voice all over this, but maybe you can shed a light on how these parties that are here today actually, go into a discussion with the government to shape the way aviation is for the future, because there are all these different possibilities, but what is the optimal one for society? How are you in discussion with with governments worldwide to tackle that?
Well, I think if you look at airports, they are mostly governmental owned, and I think you should be in favor of environmental discussions, and they should be front runners, because they're owned by governments. They have an obligation against the environment they're in. So I don't believe in profitable, to make only a profit at airports. This is a discussion we have all the time, because 80% of all the regional airports in Europe just make a loss. So they're more than just a profit center. So I think for airports, it's important to facilitate all the developments. And I think governments should do the same. Government should take care of their people. And this is, of course, it's broad. It's economics, but it's also about the well-being of people, about health, about all the developments. So I think government, they're not here. And they're working on that, because we have a duurzame luchtvaarttafel. There's a groeifonds. There are a lot of efforts taken into this. I think my main concern is all about regulations. I mean, you will see that it takes a lot of time to, of course, of the safety, but also because there are not enough people to help to make the next step. So that's my concern. It's not only in Holland, but it's also in Europe, because most of the aircraft has to be EASA certified, so it will take a lot of time. I don't know how you look at this, but this is my concern about the role of the government. It's all about regulations and how can they speed up those processes.
But you can also say there lies our strength, because we are a really safe industry. We have all those bodies in place. So,
well, hopefully but they also, I think they lack of manpower, and they have it's difficult. I mean, they have to try to make test facilities on some subjects, and sometimes it's difficult to organize a test facility, because they're afraid of liabilities or something goes wrong, They're more about fear than about positive thinking. So these are the questions I would like to ask to the government, who is not here today, but perhaps for the next time.
Next time, yeah.
Now, perhaps it's good to mention in the Netherlands we have this Groot fund proposal, Aviation in Transition, Luchtvaart in Transitie. It's worth 750 million euro, half of that being subsidy. And the important thing is that it allows us to collaborate also with other countries. So the Netherlands alone is not going to solve these issues. It's all about collaboration. And you see that there is a lot going on, for instance, with Germany, with France, also in the UK, a lot is happening. And we have to make sure that we combine all this knowledge, because otherwise we are not going to get there. But the Netherlands is doing quite a bit now as well, and we are grateful also to the government and also to the ministry for giving this money and let us participate. And now, yeah.
But it takes a lot of time to get the money there. I mean, it takes a lot of things to organize that the money can be spent sometimes.
Yeah, it's the same as usual, I would say. Yeah.
You want to add something, Brian?
Look, I led government affairs for Boeing in Brussels for 5 years, and I had a healthy amount of working with regulators. You know, in the U.S., there are a lot more incentives, and you look at, again, at the risk of starting another discussion around SAF, but in order to scale SAF, it requires a blender's tax credit or some incentives, and that's what the U.S. has just initiated through the Inflation Reduction Act. In the EU, through Refuel EU, the regulation that's going through trilogue in Brussels, it's more of a mandate. It's a mandate of 6-7% SAF production on the producers by 2030. So it's a philosophical difference. But you just gave a beautiful example with the Innovation Fund, where the Dutch government is leaning forward and trying to incentivize industry, academia to work together. So it's unfortunate she's not here, but I think government has a vital role to play, because ultimately technology is one side of the coin, and policy will unlock pretty much everything we talked about today. So write your local congressperson, but supporting you.
More questions?
Thank you very much. It's very impressive what we hear today on innovation to create a sustainable aviation ecosystem. That's beautiful. But society feels a bit different about what's happening and what we are achieving together. And I was wondering, how can we capitalize on all what is done in society to give them a real view on what's happening and what's being achieved? So maybe the next symposium should not be fueling the future, but fueling society.
That's a nice
Anne-Cor,
suggestion. Yeah, so
I think it's a very valid call. It's of course a lot about outreach. Right now, it's indeed the aviation sector where people focus on and say, well, flying is bad. It's about how do we transport? How do we get from A to B most efficiently? And I don't care however we do it. And aviation is just part of the equation. And I think this is a message we can also tell. But I think over here we are together to address what we can do in our sector, essentially. But I agree, people should, of course, we want to tell them and educate them.
I would like to add on that, because I think we are not the best people to tell the public about what's going on, because it's rather difficult to try to convince people about the fact that we are doing the good thing for a greener environment. If in every news flash that you see about CO2, the first thing they show is an airplane. Although we all know we are only 2.5%, I think, 2 to 3% of CO2 emissions. So it's a framing that we are in. We have to accept that. We cannot battle that, because then we would be trying to spreken voor eigen parochie. I don't know the English, but you know what I mean. We're not the right party to do that. But I agree with you that we should, and I think we have to tell the right story. About the 2% to start with, I think, and then we can tell the rest. But if anybody knows anybody, then I would really be interested.
Are there more questions? Yeah. And I would like to ask you to keep it short, because we are running out of time.
Yeah, thank you for the very interesting discussion. So the question I have is there, first of all, is there a consensus between the train operators or governments that let's say short-haul transportation is going to be more efficient using airplanes than trains? Because I think that's what some of you said earlier in the presentation. It was for me an eye-opener.
I'm not sure if I understand correctly what you mean. If there's an understanding between...
Yeah, so let's say, and it's clearly different between the US and Europe, but there's a highly dense train network in Europe. Yet I heard somebody say that, let's say, relatively short distances can be better served using airplanes than trains. I didn't know that. Is there a consensus that that's the case?
Well, there are many studies being conducted on this topic because the common word in the press, in the media, is that the train is is cleaner than aviation, which is true if there is already a real road lying between A and B. Because then you can transport a large amount of people in a very clean way. However, if you have to produce a new railroad to get to your new destination, or if it's very complicated because you have a long way around or crossing borders or stuff like that, then the equation is not so clear. So, to my knowledge, presently there's a study being conducted by the NLR to focus on the exact figure. So what is the real story if we're talking about emissions in the different mobilities, and also taking into account production of the concrete to build the tracks, for instance. So we have to wait on that. That's not my expertise. However, what you hear in the public debate, of course, that there are laws in the making, probably, preventing flights on shorter routes to prevent aviation on that distances. I cannot tell if that will be the case. The only thing I know that we have to get the equation right. And then I think I point again to the gentleman on your right who was asking the question about the public and about the perception we have with regard to emissions of aviation. So I think that's all related.
Yeah. Right.
Thank you.
Thank you.
One more last question.
Right. Thanks. Well, I heard this lovely discussion about SAF planes and hydrogen planes, and well, I was quite interested because once these beautiful new planes are being built and are actually flying, does it really matter when a lot of airports around the world don't have the infrastructure yet to actually fuel them? And how would you supposedly tackle that problem?
I'll start with SAF, predictably. The whole point of SAF is that it's a drop-in fuel, and what we're working on between now and 2030, hopefully sooner, is to make sure that we're also backwards compatibility between the fuels. Depending on the level of aromatics in the fuels, you have to maybe change something to the fuel system. The seals react differently. So that's the beauty of it, that we don't need an infrastructure change. And I think as we saw in some of the examples here and to our own experience on the space side, the infrastructure challenge with hydrogen is enormous. And back to the timeline we have to solve this in, that's what gives us pause, whether or not you could even do that in time. Because we have committed as society, to remind everybody, that we're going to decarbonize by the middle of the century. That's not a choice. That's a decision. And that keeps us on track with the Paris commitment. So, that's what's fueling our strategy, no pun intended.
Well, on the operation side, of course, it will be a problem. Yeah. So as an airline, if you operate a hydrogen aircraft and you have to divert to an airport where there's no hydrogen, then it's the end of the story. Before we go into that era, we have to solve these questions. We have to think about it. So, yeah, good question.
That's why there are a lot of airports at the moment working on the different kind of future fuels. And whether it's be battery or whatever, we are working really hard on that, and we share the knowledge. We also share it in European projects. So it will take some time, but hopefully I will be able to say that we will arrange this for KLM and other airlines, because without, it's a big problem, of course.
Well, that's a really hopeful message. So I would like to finish this panel. Thank you, panelists, for your contribution, and give them a warm applause.